1:03 a.m. The Sea of Japan. 39 degrees north latitude, 129 degrees east longitude. The Hwasong-17 had been on its TEL for 6 days. Its liquid fuel propellant had been loaded in a fueling sequence that required 4 hours and produced a thermal signature detectable from orbit. US and Japanese intelligence assets had been tracking the TEL since the fueling began, monitoring its position along a mountain road in North Hamgyong Province, watching the vehicle settle lower on its suspension as the propellant weight increased. At maximum fuel load, the Hwasong-17 carries enough liquid propellant to reach any point on the continental United States. That capability was the reason the intelligence picture had been transmitted to NORAD, Indo-Pacific Command, and the National Security Council within 8 minutes of fueling completion. At 1:03 a.m., the TEL stopped moving. The Hwasong-17's erection sequence takes approximately 22 minutes from horizontal transport configuration to vertical launch position. The missile's guidance system initialization adds another 9 minutes. Total time from erection initiation to ignition capability: 31 minutes. Every one of those minutes had been observable from orbit since the first U.S. reconnaissance satellite passed over North Hamgyong Province at 12:41 a.m. At 1:34 a.m., the first stage ignited. The launch plume at full thrust is visible from the Japanese coast on a clear night. The thermal signature registered on SBIRS in 0.8 seconds, the fastest confirmed correlation in the satellite system's operational history, a product of the processing algorithm update that had been deployed 4 months earlier after the previous Hwasong-17 test had taken 2.4 seconds to correlate. The notification reached NORAD, Indo-Pacific Command, and the White House Situation Room simultaneously at 1:34 a.m. The NORAD watch officer had one immediate determination to make. The Hwasong-17's trajectory in the first 90 seconds of flight would tell her whether this was a test, a high-loft trajectory designed to maximize altitude while minimizing downrange distance, keeping the missile in international airspace, or whether the trajectory indicated a depressed attack profile aimed at a real target. The two trajectory types look identical for the first 40 seconds. After 40 seconds, the guidance system's programmed burn duration begins to differentiate them. At 1:35 a.m., 41 seconds after ignition, the trajectory assessment produced its determination: high loft. The missile was not on an attack profile. It was performing a test flight. The NORAD watch officer logged the assessment. She did not stand down. A Hwasong-17 in a test trajectory over the Sea of Japan was not a threat to the continental United States. It was a provocation, a capability demonstration, and a political signal. It was also, in this particular instance, a timing event that the intelligence community had been considering for 11 days as a possible correlate to a separate developing situation 1,400 kilometers to the southwest. At 1:36 a.m., the separate developing situation activated. From hardened launch complexes in Fujian Province and from mobile TEL positions that had been repositioning across 3 provinces for the preceding 8 days, the People's Liberation Army Rocket Force initiated its strike sequence. The first DF-21D launched at 1:36 a.m. Within 4 minutes, 312 weapons were in flight. The plan package was not aimed at the continental United States. It was not aimed at Guam. It was aimed at Kadena Air Base on Okinawa, the single most operationally significant U.S. military installation in the Western Pacific for any scenario involving the Taiwan Strait, and at the USS Ronald Reagan Carrier Strike Group, operating 280 kilometers southeast of Okinawa. The package was specifically shaped for these 2 targets: 187 DF-21D anti-ship ballistic missiles against the carrier group, and 125 DF-17 hypersonic glide vehicles against Kadena's runway complex, fuel infrastructure, and the THAAD battery that was Kadena's primary terminal defense architecture. The Hwasong-17 test had launched 2 minutes before the first DF-21D left its silo. The sequencing was not coincidental. It had been the subject of coordination between the DPRK's Strategic Rocket Forces Command and the PLAN's Operational Planning Cell, through a back channel that U.S. signals intelligence had partially penetrated 7 weeks earlier, but had not fully attributed to a joint planning framework until the previous morning's intelligence assessment. The assessment had arrived at Indo-Pacific Command at 9:44 a.m., 16 hours before the Hwasong-17 ignited. The strategic logic of the sequencing was precise and had been refined over 2 years of tabletop modeling. A Hwasong-17 launch detected at 1:34 a.m. would generate an immediate response from every missile defense and command asset in the Western Pacific and continental United States. NORAD would enter full alert posture. The ground-based mid-course defense interceptors at Fort Greely would begin tracking. The Aegis BMD ships in the Sea of Japan would shift their primary sensor focus toward the northern threat axis. The THAAD battery at Seongju in South Korea would begin processing the Hwasong-17 trajectory data, consuming its fire control capacity with the highest altitude threat in the theater. Every system designed to defend against a North Korean ICBM would be in its most resource-intensive operational mode at the moment the DF-21D package appeared on radar. This was the dual-key concept. Not two simultaneous mass strikes. One mass strike and one demonstration, timed so that the demonstration's demand on command attention and defensive sensor focus arrived 90 seconds before the mass strike's first radar returns appeared. 90 seconds was not enough time to reconstitute focus. It was enough time to ensure that the first DF-21D tracks appeared on screens where human operators were already processing the most consequential decision tree in military service: the determination of whether a detected ICBM trajectory is a test or an attack. The flaw in the coordination concept was the same flaw that had appeared in every adversary's model across every engagement in this series. It had modeled the human decision cycle accurately. It had not modeled the degree to which the automated engagement network operated independently of that decision cycle. The Hwasong-17 trajectory determination at 1:35 a.m. had been generated by an algorithm, not a human. The algorithm had made its determination in 41 seconds and had transmitted it to every relevant command node before any human analyst had reviewed the raw data. When the DF-21D tracks appeared at 1:36 a.m., the NORAD watch officer's console showed two separate threat categories: Hwasong-17 ICBM, test trajectory, Sea of Japan, and DF-21D ASBM, attack profile, Western Pacific, simultaneously and separately labeled. The system had not conflated them. It had not required her to choose between them. It had processed them as two independent events and had transmitted the DF-21D notification to Indo-Pacific Command before she had finished reading the Hwasong-17 assessment. The 90-second overlap that the plan had designed as a cognitive saturation mechanism had been processed by the automated system in under 2 seconds. The human decision load it had been designed to impose had been absorbed by the algorithm before any human was asked to act on it. 1:36 a.m. USS Ronald Reagan, Combat Direction Center. The strike group had been at elevated alert status for 11 days, following the intelligence assessment that had identified the coordinated planning framework between the DPRK and plan commands. The group's 4 Aegis escorts had been in full active radar search on a rotating basis since the elevated assessment was issued. When the DF-21D track data began populating the CEC network at 1:36 a.m., the Aegis targeting computers were not initializing from standby. They were already in engagement mode, already processing the Western Pacific threat axis, already looking at exactly the vector from which the DF-21D package was arriving. The duty tactical action officer had 187 anti-ship ballistic missile tracks to process. He had been briefed on the dual-key concept 14 days earlier and had spent 4 hours in a tabletop exercise specifically modeling this scenario. The exercise had told him three things: that the Aegis network's CEC architecture would process the DF-21D tracks before a human being could finish reading the threat notification, that his primary decision responsibility in the first 12 minutes was VLS allocation sequencing, and that the Hwasong-17 trajectory assessment would appear on his console correctly labeled and separated from the DF-21D data within 90 seconds of NORAD's determination. All three things were true at 1:36 a.m. He authorized the SM-3 engagement sequence at 1:37 a.m. 61 seconds after the first DF-21D left its silo, and 17 seconds after its track first appeared on the Aegis radar. The network began generating firing solutions. The DF-21D's terminal maneuvering anti-ship capability had been the central problem of Western Pacific naval defense planning for 14 years. Against a stationary target, the DF-21D's terminal guidance package would achieve its designed accuracy. Against a maneuvering carrier executing unpredictable course changes at 30 knots, the terminal guidance required the seeker to search a corridor rather than a point, and the corridor's width was determined by how much the carrier had displaced from its predicted position during the DF-21D's 14-minute flight time, from launch to terminal phase. The Ronald Reagan had begun evasive maneuvering at 1:36 a.m., the moment the first track appeared on her screen. 14 minutes of evasive maneuvering at 30 knots in unpredictable direction. Changes would displace the carrier from any predicted position by a distance that the DF-21D's terminal seeker might or might not be able to compensate for. It was not a guarantee. It was a probability improvement that the carrier's commanding officer was required to pursue regardless of the outcome probability. The SM-3 engagement against 187 DF-21D tracks began at 1:38 a.m. The Aegis network across all 5 platforms was generating firing solutions at maximum throughput rate. Under CEC, one ship's radar track fed another ship's intercept, distributing the engagement load across the combined VLS capacity rather than concentrating it on the ship with the best radar geometry. The SM-3 Block 2A's engagement probability against a DF-21D was modeled at between 55% and 72%, depending on the intercept geometry, a lower confidence than the system achieved against conventional ballistic missiles, because the DF-21D's terminal maneuver capability degraded the intercept solution in the final phase. Of 187 DF-21Ds in the first wave, 114 were intercepted during the mid-course or early terminal phase, between 1:38 a.m. and 1:49 a.m. 73 entered their terminal search phase. The THAAD battery at Kadena was simultaneously processing the DF-17 hypersonic glide vehicle package, approaching from the west. 125 DF-17S, in their depressed glide trajectory, maneuvering at Mach 5+, required SM-6 engagement from the Aegis network, because THAAD's fire control geometry was less favorable against the DF-17's altitude band than SM-6's active seeker. The THAAD battery was covering the conventional ballistic missile elements of the Kadena target package, while the Aegis SM-6 was assigned to the DF-17 threat class. The dual processing load on Kadena's combined defense architecture was exactly what the plan had designed. THAAD managing one threat category, while SM-6 managed another, both systems at near maximum engagement rate simultaneously, both consuming their ready load inventory at a pace the battery commanders had pre-flagged as the threshold monitoring priority for this engagement. Of 125 DF-17S targeting Kadena, 81 were intercepted by the combined SM-6 and Patriot PAC-3 MSE architecture between 1:40 a.m. and 1:52 a.m. 44 entered their terminal phase against the Kadena target set. The Kadena THAAD battery reached its ready load threshold at 1:51 a.m. 11 minutes of continuous engagement against the DF-21D elements of the Kadena package had expended its preloaded interceptor supply. The reload window was 11 minutes. The Patriot PAC-3 layer absorbed the rerouted assignments from the depleted THAAD battery and continued the engagement against the terminal phase DF-17S with reduced engagement probability per intercept. 26 DF-17S impacted the Kadena target set between 1:52 a.m. and 1:58 a.m. 3 impacted the primary runway complex in a pattern that achieved the plan's runway denial objective. 2 sections of the primary runway were structurally compromised. The parallel runway received 1 impact. Kadena's primary flight operations were suspended. The pre-positioned rapid repair teams were on the surfaces within 6 minutes of the last impact. Initial assessment: primary runway operational in 4 hours. Parallel runway in 2. 4 impacted the fuel farm. 2 of the farm's 6 fuel lines were rendered non-operational. 4 impacted in the THAAD battery's operational area during its reload window. The plan had correctly calculated that the battery would reach reload threshold and had timed a portion of the DF-17 package to arrive during that specific window. The battery's reload crew was not on the launcher when the impacts occurred. They had moved to their protected positions when the battery threshold was reached. The launcher infrastructure sustained damage. The battery's reload was delayed from 11 minutes to an estimated 40 minutes for damage assessment and partial system reconstitution. 18 additional DF-17 impacts were distributed across logistics facilities, fuel infrastructure, and maintenance areas. Kadena was significantly degraded. It was not eliminated. Back at sea, 73 DF-21Ds had entered their terminal search phase against the Reagan's operating area. The Reagan had been maneuvering for 14 minutes. Her displacement from the plan's last confirmed position fix was 34 kilometers, at the outer boundary of the DF-21D's terminal seeker search corridor. The seeker's acquisition probability against a target displaced 34 kilometers from the predicted position was modeled at 41%. 59% of the terminal phase missiles would fail to acquire. 59% of 73 is 43. 43 DF-21Ds failed to acquire the carrier in their terminal search phase and impacted in open ocean. 30 DF-21Ds acquired. Of those 30, 19 were engaged and neutralized by PAC-3 and CRAM during the terminal phase. 11 closed to CIWS range. 8 were neutralized by CIWS. 3 impacted USS Ronald Reagan. The first struck the flight deck's aft section, penetrating through the deck surface and detonating in the lower hangar bay. The second struck the carrier's island structure on the starboard side, destroying the primary radar array and the flag bridge. The third struck the hull at the waterline on the port quarter, creating flooding in 2 after engineering compartments. The damage was the most severe sustained by any U.S. carrier in this engagement series. The flight deck impact and hangar bay detonation rendered the rear 2/3 of the flight deck non-operational. The island impact destroyed the primary radar and the flag bridge. The strike group commander and 2 members of his staff were among the 11 personnel killed on the island. Command authority transferred to the Combat Direction Center below decks within 40 seconds of the impact, as per continuity of command protocol. The waterline flooding was assessed as containable. The damage control teams had the affected compartments isolated within 16 minutes. USS Ronald Reagan was not sunk. She was fighting for operational continuity. Her forward catapults were intact. The forward third of her flight deck was structurally sound. Her Combat Direction Center was operational. Her propulsion was unaffected. She was capable of generating strike sorties from the forward deck position at reduced rate. The carrier remained in the fight at severely degraded capacity. By minute 22 of the combined engagement, the United States had expended $3.4 billion in interceptors and counterstrike munitions. The figure included the THAAD and Patriot expenditure at Kadena, the SM-3 and SM-6 campaign against the DF-21D and DF-17 packages, and the initial Tomahawk salvos from pre-positioned Virginia-class submarines that had begun engaging PLARF infrastructure at 1:48 a.m. under Operation Steel Meridian. The Hwasong-17 had continued on its loft trajectory throughout the engagement, reaching a peak altitude of 6,200 kilometers before beginning its descent toward the Sea of Japan. It impacted in international waters east of Hokkaido at 1:51 a.m. The NORAD assessment trajectory had never changed from test flight classification. It had not been intercepted. The ground-based mid-course defense interceptors at Fort Greely had been in tracking posture throughout, and had generated engagement solutions that were not released because the trajectory assessment had remained at test flight confidence throughout. The missile had been a Hwasong-17 test. It had also been a timing device. The timing device had not worked as intended. The automated network's separation of the two threat categories had prevented the cognitive saturation the plan had designed. But the timing device had achieved one thing its designers had correctly anticipated. It had kept the ground-based mid-course defense system in tracking posture throughout the DF-21D engagement, consuming Fort Greely's command attention and precluding any reallocation of that system's capacity toward the conventional anti-ship threat. That resource consumption had not been decisive. It had been a tax on the system's available attention that in a more complex or larger engagement could have been the variable that mattered. The DPRK had not contributed a weapon to the engagement. It had contributed a distraction. The distraction had cost the system 40 seconds of additional processing. In this engagement, 40 seconds had not changed the outcome. In a longer or more complex scenario, the arithmetic of 40 seconds would be calculated differently. The counterstrike under Steel Meridian targeted the PLARF launch infrastructure with the same architecture that had been used in the Pacific scenario. Virginia-class submarines pre-positioned in the Philippine Sea and east of Taiwan provided the Tomahawk magazine. B-2 Spirits from Whiteman held their orbit points waiting for the political authorization for mainland China strikes that had not been received. JASSM-ER from B-1B, Lancers at standoff range, engaged the Fujian Coast TEL complex surface infrastructure. EA-18G Growlers provided continuous electronic suppression of plan air defense radar networks. The authorization question for DPRK counteraction was a separate thread. The Hwasong-17 had been a test flight. It had not impacted U.S. or Allied territory. The DPRK had not fired on any U.S. asset. The political authorization framework for a military response against DPRK territory, in response to a test flight that had been correctly classified as non-threatening, was not available under the current rules of engagement. The intelligence community's assessment of the DPRK plan coordination framework was compelling, but had not been tested in a legal standard that met the threshold for kinetic action against a sovereign state that had not itself conducted an attack. The DPRK had fired a test missile. It had coordinated that test missile with an adversary that had conducted a mass anti-ship strike. The coordination was documented. The legal threshold for response remained the legal threshold for response. That question would be resolved in offices that were not on the carrier. 2:44 a.m. USS Ronald Reagan, Combat Direction Center. The command authority had transferred to the Combat Direction Center at 1:58 a.m., 60 seconds after the island impact. The officer who had assumed command had been briefed on this contingency 18 months earlier and had rehearsed it in an exercise 12 months before. The rehearsal had not included the specific condition of managing a fight while the ship's primary radar array was non-operational, and the flag bridge personnel were among those lost. The Combat Direction Center's below-decks radar repeaters were fed by the ship's secondary radar array, which had not been damaged. The tactical picture was complete. The engagement data was flowing. The ship's defensive posture was intact. The forward flight deck was being assessed for sortie generation. The preliminary report from the forward deck crew was that the catapults were operational, and the first aircraft recovery and rearm cycle could begin in 31 minutes. At 2:44 a.m., the first post-strike F A-18F landed on the forward section of the flight deck. The aircraft had been airborne since before the first DF-21D had left its silo and had expended its weapons in the cruise missile intercept phase. It landed, was rearmed, and launched again at 2:52 a.m. The launch was logged in the sortie record. The sortie record did not note that it was the first launch from a carrier that had been hit 3 times in the preceding 46 minutes. It was a sortie. The carrier was still generating sorties. That was the data point that mattered. Time from first, DF-21, D-launch detection, to last, PLARF infrastructure, Tomahawk impact in initial salvo, 72 minutes. Time from first DF, 21D to last DF, 17 impact on Kadena, 56 minutes. DPRK Hwasong-17 ICBM, test trajectory, Sea of Japan impact, no U.S. response authorized. Plan first wave. 187 DF-21D anti-ship ballistic missiles against carrier group. 125 DF-17 hypersonic glide vehicles against Kadena. DF-21. D-intercept results. 114 of 187 intercepted in mid-course and terminal phase. 61% rate. 43 additional failed to acquire in terminal search. 30 acquired carrier. 19 neutralized by PAC-3 and CRAM. 8 neutralized by CIWS. 3 impacted USS Ronald Reagan. DF-17. Intercept results. 81 of 125 intercepted. 64.8% rate. 26 impacted Kadena target set. 18 additional impacted non-critical areas. Physical effects. USS Ronald Reagan. 3 warhead impacts. Flight deck aft section non-operational. Island destroyed. Waterline flooding controlled. 11 personnel killed, including strike group commander. Command transferred to CDC. Forward flight deck operational. Sorties generating at 1:52 a.m. Kadena. Primary runway non-operational 4 hours. Parallel runway non-operational 2 hours. THAAD battery damage requiring 40-minute reconstitution delay. Fuel farm, 2 of 6 lines disabled. Counterstrike Steel, Meridian. 144 Tomahawk against PLARF-TEL complex infrastructure. 62 JASSM-ER against Fujian coast positions. 22 AARGM-ER against Plan coastal radar network. 3 Renhai cruisers confirmed in pursuit contact by SSN escort. Total counterstrike cost, approximately $2.1 billion. Total engagement cost, including all interceptors, $3.4 billion. The plan had assembled a dual-vector concept that had achieved more physical effect than any previous adversary in this series. 3 warhead impacts on a carrier. Kadena's runway complex temporarily denied. The strike group commander among the killed. The THAAD battery at its reload threshold during the most critical window of the engagement. And still, the carrier was generating sorties at 1:52 a.m. Kadena's runway repair crews were already on the surface. The Combat Direction Center was operational. The counterstrike was in flight. The dual-key concept had been correctly designed around the human decision cycle. It had not been correctly designed around the automated network that preceded the human decision cycle by 90 seconds. The 90-second overlap had been the plan's critical assumption. The network had processed it in 2 seconds. That was the margin by which the cognitive saturation mechanism had failed. Not because the concept was flawed, because the system it had been designed to saturate had been updated 4 months earlier to process exactly that scenario 37 seconds faster than the previous version. 4 months. A software update. The margin was measured in version numbers.